Okay, so we learned the three cases and we did all of them to second degree polynomials or quadratic equations. Now, how about if we get a differential equation that has an order higher than 2? Okay, now if you have a differential equation which has constant coefficient, which is linear, which is homogeneous, then we can use the same method, right? Think about it. You can use your general solution, to be look like e to the mx. Well, you can substitute into that differential equation, you can come up with an auxiliary equation. But this could be a third degree polynomial, fourth degree polynomial, fifth degree polynomial, but still you can find roots, right? So it's all about finding roots. Okay, let's look at them from an example. Okay, so here we have a third degree differential equation, third order differential equation. Now you substitute e to the mx to the differential equation along with y prime, y double prime. Now you have to substitute y triple prime also here, right? That's the error. Okay, so now when you substitute it, you get this expression and you get the auxiliary equation that is given here. Now this is a third degree polynomial, right? So you have to factorize it. Well, you have to find the roots. So finding roots is not the primary concern here. So we will not do that here. Let's assume the roots are given to you. How can we write the general solution? Let's learn that. I think that's much more important. So let's say you somehow factorize this. You got your roots to be -1, 2, and 5. Now how would you write the general solution? Think about those three cases. Which case is this? Distinct roots, right? You have -1, 2, and 5, three different roots. So your solutions are e to the -x because of -1, e to the 2x because of 2, e to the 5x because of 5. So now what is the general solution? C1 times e to the -x plus C2 times e to the 2x plus C3 times e to the 5x, right? So that is a distinct root case, but for a third order differential equation. Okay, let's look at another example. Let me show you some really interesting examples. Okay, here now we have a fifth order differential equation, and let's say we get the auxiliary equation this. Now what are the things that you should know about higher order differential equation? You should be able to definitely get the auxiliary equation. Okay, factorizing a fifth degree polynomial, that's not something that we expect from you. But instead, how about if we give the roots for you? Then you should be able to find the general solution, okay, based on those three case arguments. Now here, let's see. So let's say someone factorized this for you and you get the root to be -1 but repeated 5 times. So repeated roots, this falls into the second category. Now how do you find the solutions? We know for sure one solution is what? Root is -1 e to the -x. That's the first solution. Second one, we learned that we can multiply by x and get the second one. How about the third, fourth, fifth one? Are you going to do reduction of order? Well, that would be the way, but we have a shortcut. The shortcut is you can keep on multiplying by x, the previous solution. So the next solution is you multiply this solution by x square, right? Then it becomes x square to the -x. So fifth order differential equation, how many solutions you should have in the fundamental set? 5, right? So we already have 3. So keep on multiplying by x. So x cube e to the -x. Now we have 4. x4 e to the -x. That's the final one. Now you have 5 pieces in the fundamental set of solutions. Now you take the linear combination of them, then you can write the general solution. Okay, so you keep on multiplying by x when you have repeated parts. All right, so let's see another example. These are really different examples. Okay, so be with me. Here we have a fourth order differential equation and the auxiliary equation is this, and they say the root is plus or minus I repeated 2 times. Okay, now what is the solution? Now repeated 2 times means, so this is a fourth order differential equation, so we should have 4 roots. Well, we know alpha here is 0, beta here is 1. So tell me the first set of solution. Well, e to the alpha x or e to the 0x cosine x, right? E to the 0x sine x. That should be the solution for, just forget about the repeating times. Let's forget it's repeated. For plus or minus I complex root, this should be the solution, right? 2 parts. Actually, then e to the 0x is 1. So it's cosine x and sine x. So your solution will be y is equal to c1 cosine x plus c2 sine x, right? But now then, how about you deal with repeated complex roots? So you have already 2, you need another 2. Multiply by x, right? So the next one is x cosine x, other one is x sine x. Now you have the 4 parts. Now you can generate the general solution. Okay. All right. Let's look at another very important example. Oops. So we have a 5th order differential equation. We get the auxiliary equation. Let's say we have one root to be 0, repeated 2 times, m2 to be 1, repeated 3 times. Okay, how would you write the solution here? Very tricky. Let's do it slowly. So for 0, first solution will be e to the 0x, which is 1. The second one should be, because it's repeated, you multiply the first one by x. So it's just x, right? X times e to the 0x is x. So that is, we are done for m1 is equal to 0 root. So it's 1 and x. Now let's go to the other root. Other root is 1. Now the other root is 1. So the first solution will be e to the x. Now you don't start this with multiplying by x or x square, okay? You don't multiply it by x because you had the previous root to be repeated. These 2 roots are 2 different roots, 0 and 1. Okay, so you treat them differently. For 0, I know it's repeated, so you wrote the 2 solutions, 1 and x. Now keep that aside. There's no connection with 1. Now 1 you start as e to the x. Then the next solution is x e to the x. You need another one because this is 5th degree. You only have 1, 2, 3, 4 now. The other one is x square e to the x. So you keep on multiplying by x within a 1 root, if a 1 specific root is repeated. Okay, so you don't multiply every root solution by x. Okay, so you just do that for the root that is repeated and its solutions. Okay, so the solution set will be e to the x, x e to the x, x square e to the x. Okay, what was I am saying is, someone might think this as 1x, x ex, x square ex, x cube. No, that's wrong. Okay, you don't multiply, you don't keep on multiplying everything by x. That's not relevant. You just multiply by the relevant parts. Okay, that is how we deal with high order differential equations. Okay, all right. Thank you very much.